All right, good afternoon, everyone. Let me start with a quick announcement. One of your classmates pointed out that the Cygwin download in the syllabus doesn't work anymore. I guess they're not hosting it anymore. They used to have a self-extracting zip file there. So what I've done, I've made one. So if you do want to use JGrasp on your local computer, you can download this one. It's very big. I always about 4 gigs, so it's going to take a little while to download. Oh, I thought I had it here. I was going to show you. When you try to open it up, it's going to ask you where you want to put it. Put it in your C drive. So this is only if you're a Windows user. Don't download this if you're not a Windows. You don't have a Windows machine. But put it in your C drive. That's where JGrasp is going to look for it. All right, with that being said, let's see. We are still going through chapter 1. So let's try to finish up chapter 1 and then get into chapter 2 today. Oh, I need to open up my chat. So just a quick review. We talked a little bit about binary, and we kind of hinted at why it's important, right? Because all computers use the idea of binary to communicate. I guess to dig a little deeper, most of us in here are probably electrical engineers. The way computers work, they work by interpreting electrical signals. If a transistor has a charge over a certain amount, it's interpreted as a 1. If it's charged less than that amount, it's interpreted as a 0. So binary is a really convenient way to try to talk to the computer, if you would. You have a lot of transistors, and they all have some electrical charge on it, and we can interpret it as 1s and 0s, and that kind of gets translated into everything that you see today. So binary is important when we're talking about variables, which I believe we moved on to variables. All variables have a size. They have a certain size depending on their data type, and that determines how much you're allowed to store at that memory location, right? So what is a variable is really just a way for you to reference a physical portion of your RAM, right? So RAM is memory. Variables exist in your memory. So another FYI for those that may not have known, when you run a computer program, it doesn't actually run off your hard drive. It's stored on your hard drive. That's a more permanent type of storage. But when it's time to actually use it, what the computer will do, it'll take that program off the hard drive and it'll put it in memory. It'll put it in your system's memory because it's faster. The hard drive's too slow. So those variables exist in memory somewhere, and when you're using a computer program, that variable name is a reference to a specific memory location, and that memory location has a certain size that's determined by the data type. So we'll come back to this later toward the end of the semester when we talk about pointers, and we'll actually start managing memory somewhat on our own by the end of the semester. But definitions. So let's just quickly recap these functions. What is a function? A function, the idea of what a function is anyway, you can think about it like a named set of instructions. So what is a function? It's a named set of instructions. It's a little more than that, and we'll actually talk about that once we start. That's going to be the first topic we cover in here is functions. What are libraries? Well, libraries are collections of those named functions. And compilation, what is that? Compiling something means taking that source code file. It's just a text file, like, you know, that's something you would write in Notepad or whatever text editor you have in Mac. It's just a text file with words in it. And what the computer does is it takes that text and it converts it to binary. It converts it to machine instructions. That's compiling. That's what compilation is. Taking those words and converting it to an executable file that your machine can understand. All right, variables and data types. I believe we stopped around this area. So what is a variable? It's a placeholder. Very simply, we can say that a variable is a placeholder that we can use to store values, right? So I gave the more correct explanation earlier, right? That we don't really have to think too much about now. A variable is a named reference to a physical memory location that has stuff in it. But we can think about it like this, at least for the time being. A variable is just a placeholder, someplace you can store things. Variables have data types. You can think about the data type like a label. So if you have a variable called X, the computer needs to know what kind of information is there. So remember, we said everything is in binary, and the computer translates it. It translates those ones and zeros, and it'll mean different things given different contexts. So if this is a string, those ones and zeros have a different meaning. If this is a number, those ones and zeros have a different meaning. So depending on what type of information that variable is, what data type it is, the computer will interpret those ones and zeros differently. So data type is that label that you apply to a variable to tell the computer what kind of information it's storing right there. So here are a couple of data types and what they are called in C. So floating point numbers, this is an example of a data type. And this is just any number with a decimal point, 2.6, 5.1, 2.0. Anything with a decimal point is a floating point number. It can represent those decimal places. You have in C, the official name for these data types is either float or double. We're going to use mostly double in this class. It's easier to work with. But the only difference is that float is smaller, right? So a float, because it uses less bits. Remember, we said a bit represents it's like an equivalent to one digit of a number, because there are less bits that are used to represent a float. You can't represent as large a number as you can with a double. A double is twice as big as a float. So you have higher precision. Here's the official description. They said, at least according to IEEE standard, a float should be able to accurately represent up to 7 decimal places. It says 7 digits. It should be 7 places after the period. Whereas a double should be able to accurately represent a number with up to 15 decimal places, that amount of precision. More than that, it can represent it, but it may not be accurate. It may not be correct. Whole numbers. So it is pretty intuitive. Anything that's just a whole number, 2, 4, 10, -6. These are all examples of whole numbers with no decimal place. There are 3 data types in C that represent whole numbers, short, int, and long. We are going to use the one in the middle in this class. So short, and again, these all just represent varying amount of storage. So short is the smallest, maximum size of 2 bytes. Int, depending on your operating system, it's either 2 or 4 bytes. And long, maximum is going to be 4 bytes. Oops. Characters. A character is this data type represents single characters. A space is a character. A number is a character. A letter of the alphabet is a character. A punctuation symbol is a character. So all of these can be stored using the character data type. If you have lots of characters together, like a sentence, we would call that a string. Now, C doesn't have a data type for string. Some languages do. C does not. If you've gone through chapter 1 already, you'll see that C has a special way of treating strings, of dealing with strings. It's an array of characters. I know we haven't learned what an array is. An array is a special type of storage that can use to be stored more than one item of the same data type, right? So in that case, multiple characters. We will talk more about arrays later. And Boolean, the Boolean data type, some languages support this as a data type, C does not. But the Boolean data type just represents true or false. Okay. All right, well. That's cool. Sorry, online students. My projector gave up on me. Give me just a minute to try to get it going again. All right, the projector is coming back out. Hopefully we'll be ready to go soon. All right, there we go. All right, back to the lecture. So the Boolean data type, the only values you need to represent are true or false. The way this is handled in C, the way this is handled in C is that anything that is not the number 0 is interpreted as true. So the number 0 is false in C, everything else is true. If you do want to use that as a data type, there are libraries, or there is a library that someone else wrote that you can import, and then you can use the word true or the word false to represent a Boolean character. You can use the Boolean data type. So how do you use a variable? Let's talk about using variables in C. There are a couple of things you have to do. The first thing you have to do is tell the computer that it exists. All right, first you have to say that it exists. How do you do that? You declare it by typing in the name of the variable preceded by some data type. So if you take a look at line 1, or this first line here in the example, that's the name of my variable. This is my data type label, int. It's short for integer. So this is going to be a variable that's able to store a whole number. And in C, every time you complete an instruction, you indicate that by typing in a semicolon. So this semicolon here indicates the end of an instruction. I finished writing one complete instruction. The next thing you have to do is define it. So you should not use a variable before you give it a value. Sometimes you can do that, and it's not good to do that. And we'll talk about why that's possible later in another lecture. But for now, before you can use this variable, you should give it a value. And the way you do that is through an assignment statement. So in C, the equal sign always represents an assignment statement. The equal sign never means anything else. It's always an assignment statement, and it always works the same way. An equal sign always takes some value on the right and stores it inside some variable on the left. It's always right to left. And the thing to the right must have a value, and the thing to the left must be a variable. So define it, you give it a value. We're going to do that through an assignment statement. That's what we call the equal sign. This assigns the value 10 to the variable called num1. And of course, we have the semicolon indicating that we're done with that instruction. And once you've done it, you can reference it anytime you want to by just typing in the name of the variable. So if we take a look at the rest of this example, you can see I declared a variable called num1. It's an integer. I defined it. I gave it a value. Here, I did both steps at once, right? So I did step 1 and 2 at the same time. I declared a variable called num2, and I also assigned it a value. So you can do this in C as well. You can declare it and give it a value at the same time. This is called initializing it. When you give it its first value. And then below, I'm going to kind of repeat that. I'm going to make a new variable called answer. It's also an integer. And I'm going to assign it a value. And what's the value going to be? It's going to be num1 plus num2. So we can take this expression here, and we referenced num1. So when I type this variable name in, the computer is going to go look at num1, say what's stored here. Okay, and it's going to substitute that value for you. And we'll do the same thing for num2. So 10 plus 4, it'll calculate that result, and it'll save that value into this variable called answer. This variable called answer. And if you want to, you can change these values. So that's not permanent. Later, if I want to change num1 so that it equals 20 or 30 or something else, you just type in num1 equals and whatever new value you want it to equal. So there are a couple of rules, not many, for naming variables. If you want to come up with a variable name in C, you're limited to a certain range of characters. You can only use underscore symbols, any upper or lowercase letter, and any number. So a variable name in C can only be comprised of letters, numbers, and the underscore symbol. You're not allowed to use anything else for a variable name. The other rules, one is that the first character has to be an underscore or a letter of the alphabet. So a variable name can have a number in it, but the number cannot be the first character of the name. So we opened up Notepad, for example. One, that's okay for a variable name. I have letters and numbers in it. That is not okay because the first character is a number. So you can't begin a variable name with a number. It has to begin with an underscore or with a letter of the alphabet. And of course, it can't be a reserved keyword. So there are some words that are reserved for use with C. They have a special meaning in C, and you're not allowed to use those. And we'll go over several of those as we go through the semester. Naming conventions. So these aren't rules, but these are suggestions that most people try to follow. When you're creating variable names, try to use a name that means something. I think it was this class where I mentioned it's common to see computer programs that are hundreds of thousands of lines of code, right? So when you have something that is hundreds of thousands of lines long, it's very easy to forget what something means, on line 50,000. So when you're making variable names, try to give it a name that means something. So if I wanted to write a program representing a bank, some kind of bank application, right? Maybe I could make a variable name. I might call this one bank account, right? That might be a variable name I could use instead of X, right? So let's say I call it X, then on line 20,000, I need to refer to some bank account. I don't remember what I called it. I don't even know what X is anymore, right? So use a name that means something. So when you're looking over it, you understand it. It helps you understand what that variable is being used for. And the other convention is how you write multi-word variable names. So it's common to have variable names that consist of multiple words, especially if you're trying to create names with meaning. So for example, bank account, we'll just use that example, maybe username, right? So the conventions here are, if you have, there are two predominant conventions for multi-word variable names. Number one, you always put underscores between the beginning of the new word and the last word. So bank account, I would put an underscore between these two words. So you're allowed to use underscore in variable names. And now this is easier to read. Bank account, it's easier to read multiple words. The other naming convention is that you capitalize the first letter of every new word. So here, user name, some very long variable name, right? This is very difficult to read, right? So to make it a little easier, we could do something like this, some very long variable name. Personally, I don't like this very much. I prefer the underscore, but these are the two predominant conventions here. If you're going to have a multi-word variable name, put underscores between the word or capitalize the first letter of every word. And we looked at an example, so we'll skip that for now to try to get through some of this. So constants, I mentioned earlier that in C, once you make a variable, you can assign it different values. It doesn't always have to have the same value. Well, why don't we open up JGrasp? Let's open up JGrasp so we can look at an example. We can kind of do examples as we go through this. Oops. So let's just make a simple program. We'll make a variable int x, and we'll just give it an initial value of 10. And I'll go ahead and print it. You should, I think chapter 1 talked a little bit about printing, so they should have talked a little bit about format specifiers. We'll talk more about that in just a moment. But here I'm just going to print the value of that variable, and we'll run it, and you can see it has a value of 10. That's right, that's what x is. If I wanted to, I could change x. So let's change that, and we'll just reprint it. We'll compile it again. So remember, first we have to compile it. We have to convert these English words into something that the computer can understand. And then we're just going to click the running man to run it. And we can see that I'm printing the same variable, but I changed the value here. So you can change the value of a variable. That being said, a variable can only have a single value at any point in time. So when I used x here, it still only had a single value. It can't be 10 and 20, right? It can only be one value, but you can change it. And whenever you use it, whatever the last value was that you set it to, that's what the value of that variable is going to be. So notice when I print x here, it's not 20. Right, so we read the instructions from top to bottom. First, I'm going to do this, then I'm going to do this, then I'm going to do that. We could label these instruction 1, instruction 2, instruction 3. That's how the machine is going to interpret these instructions. Now, that being said, there is a way that you can create variables that are immutable. They can't be changed. So they're called constant variables in C. A constant is a variable whose value you cannot change. There are a couple ways to do that in C. One is by using this pre-processing directive. Recall we talked about that on an earlier slide. I skipped it today, but we did talk about it last week. These are pre-processing directives. These are things that happen before the computer begins to compile the code, right? So here I can define a variable, and we'll just do capital X equals 1. Right? And we can't change that. That's always going to be 1. I can print it and I can use it, but I can't ever change the value of that variable. I could also do this. Oops. I could also do this in front of the word int when I declare this variable. I could say this is a constant. Now you have to do this when you create the variable. If you label this, if you put this label in front of that variable declaration, then we'll see when I try to compile it, I should get an error code, an error message. And what does it say? It says on line 10, here's line 10, there's an error. I'm trying to make an assignment of a read-only variable. So X is read-only. When I made it constant, I made it so that you could not change that value. So once you give it that initial value, that's it. It can never equal anything else. This is always going to be 10. So you do have the ability in C to make variables that can't be changed. And finally, another way that you can provide a value in C is just by providing a literal. What is a literal? The simplest way I can describe this, a literal is just any value that's not saved into a variable. That's it. This is a variable. It has a value. I can do that if I want to. I can type in 20 and a semicolon. Nothing's going to happen, but if I wanted to, I can do that. This number right here, this is an example of a literal. It's a value that I have not saved into a variable. Hello, that's a string. So this is a string literal. It's a value that I have not saved into a variable. So a literal is just any value that you haven't saved into a variable. This is a string literal. We'll talk about parameters when we start talking about functions, but this is a string literal. This is a string. I don't have it saved anywhere. I just made it on the fly and I only get to use it once. If I want to use it again, I have to type it again or copy and paste it. Versus this variable, if I want to use this variable again, I don't have to type the number 20 again. I just type in X. Sometimes it is useful to pretend that a variable is a different data type. So for example, right here, I made this variable called X and I declared it to be an integer. This is a whole number, but maybe I need a double. There are some functions that want to receive information in a different way. I don't want an integer, I want a double, or I want a float, or I want some different data type. In C, it's possible to pretend that this variable is something else by doing something called casting. And to cast a variable, all you have to do is in front of the variable, when you're using it, you write the data type you want it to be surrounded by parentheses. Now, let me just show you one example here. Here, I'm going to print X, but I'm going to print it. LF stands for long float. That's a double. So that's the pattern specifier for double. What I'm telling C is that I'm going to give you a variable, but I want you to interpret it as this data type. So I'm going to interpret that as a double, and you'll see doubles and whole numbers aren't interpreted the same way. And if we try to print it, you can see, what did I print? Well, I printed 0. Well, that's not 0, that's 10. But if I were to interpret this as a double, that's what it would equal. If I took those ones and zeros and I interpreted as that data type, that's what it's going to equal. So what could I do? Well, I could cast it. I could use the correct data type, or I could cast it to a double. I can just say, you know what? I know you're a whole number, but for now, I want you to pretend to be a double. We'll compile it and we'll run it. And we'll see that now it prints correctly. This is the number 10. And this doesn't change the data type, okay? Just momentarily pretends that it's a different data type. If I use it again immediately below it, this time I'm not going to cast it, but I'm going to print it as an integer because that's what it is. It should still print correctly. And sure enough, it does. All right, so you can cast a variable from one data type to another by preceding the variable by the data type you want to cast it to, followed by parentheses. But you do this when you're using it, right? So that's not permanent. This is only good on line 8. After I finish this instruction, it's not a double anymore. Format specifiers. So a format specifier, I've kind of hinted at that because I've been using them here. This is an example of a format specifier. That's an example of a format specifier. That's when you want to substitute something for those characters. So in this example, let's do a regular print statement. Printf hi. right? So here I'm going to print hi, and this is what I'm printing. I'm printing hi, and then I'm printing a new line. New line is like hitting the return key. So let's compile it. And I can run this as many times as I want to. That's always going to print hi. On the other hand, this will print whatever I put right here, as long as it's a double, right? So I'm going to change that to 4.56. It's going to substitute this for that. So a format specifier is some data type that you're going to put in your string that indicates you want to make a substitution. When you print this, I don't want you to print LF. I want you to print something else. And here's the data type of that thing. If you go to this link, you can see all of the different format specifiers that exist in C, as well as other information, other things you can do. For the time being, the ones we care about, let me see if I have it here. The ones we care about are going to be D, so it's a percent sign followed by some letters. D for decimal number, LF, that stands for long float, that's for doubles, C for character, and S for string. Those are the four that we really care about in this class that we're going to use the most. The other thing you can do with this, if I put something in between for some format specifiers like strings or floating point numbers, you can make some additional arguments, and you can find them here if you go here. But I can do something like 0.2. That means I only want to print up to 2 digits after the decimal place. And if we print it, you'll see that it only prints 2 digits. Well, I only have 2 digits. Do that. If I print it, we'll see that it only prints 2 digits after the decimal place. I didn't change the number. I just didn't display the rest of it. Right. So there are other things you can do by inserting things in between the percent sign and the format specifier that you want to use. The printf, you've seen me use it. Let's talk a little bit more about how this function works. Printf is an example of a function. And what it does, it takes some string and it prints it on your computer screen. That's what it does. So if we look at this example here, I took this string, it's the word hi, followed by an enter key, and I printed it right here on the computer screen. Here I took this string, I made this substitution, and then I printed that on the computer screen. So that's what printf does. The way it works, you start by writing a string. Typically, we're going to use a string literal. That's what most people do. You could put a variable there, but most people use string literals. You put the string that you want to print in between the parentheses. So you write printf, that's the name of the function, followed by parentheses, followed by the string you want to print. Sometimes you want to make substitutions, like this case here. Sometimes I want to substitute values for that string. I don't want to print exactly that. In that case, you include those format specifiers in your string, and for each of those, you include that value as a comma separated list. So let's do something easy. Let's say number, space, number, space, number. So this is going to print some number followed by a space, followed by another number, followed by a space, followed by another number, followed by the enter key. And what I need to provide here for each of those format specifiers, I need to provide a value. It can be a variable or it can be a number. So I give it 3 values. And when I'm printing this string, I'm going to say, okay, you want to make a substitution? I'll grab the first item in the list. You want to make another substitution? I'll grab the second item in the list. You want to make another substitution? I'll grab the third item in the list. So if we compile this and run it, it should print 10, 10, 20. So standard IO, this is a library that includes some pre-written functions that we're allowed to use. Printf is one of them. I've been using this one. Another one is scanf. So standard IO stands for input and output, standard input and output. there are a lot of functions that allow you to read and write from the screen or from the keyboard. So scanf, we've looked at a way where I can take something in my computer program and put it on the screen. But what about capturing input? What if I want to be able to accept input from the user? Maybe you can type something to the keyboard and I can use it in my computer program. That's what scanf is for. And it works very similar to printf, except the only thing that you should put in your string is a format specifier. What I'm saying is when I use scanf, you're about to type something into the keyboard. This is what you're going to type in. You're going to type a number in. Then you type the number into the keyboard, you hit enter, and it's going to save it into some variable. So here I have a variable x. Let's make it not a constant anymore. And we're not going to give it a value yet. Let's just do this. So if we try to print it, it should complain. Yeah, print 0. So it doesn't have a value yet. We're going to give it a value using the scanf. We're going to type in the function name, followed by a format specifier. So our string is just going to be the format specifier and nothing else. And what is it? It's a whole number. So it's expecting me to type a whole number in. So I'm going to type %d. I'm going to give you a whole number. And then we're going to put the variable name, but in front of it, we have to use the ampersand. Again, we'll talk more about that later in the semester, but for the time being, recall I mentioned that a variable name is a reference to a physical memory location somewhere on your RAM. It's pointing you to an address on your RAM. Go here. The ampersand symbol means go to this address. So typically when you use the variable, that's not the way we think about it. It just give me this value, retrieve the value. And that's what it'll do. It'll go to that address and retrieve the value. When you put an ampersand in front of it, it literally just means go to this address. So here, what we're saying is you're going to type something into the keyboard. I'm going to interpret it as if it were a whole number, and I'm going to put it right here in memory. All right, so that's what that means. So let's save this and let's run it. And notice it's just kind of blinking and waiting. So that's scanf waiting because I didn't know it was going to ask me anything. I'll go ahead and type in a number. And we can see now, sure enough, it saved 33 into X. And when I tried to print it, I could see that. Typically, if you're going to use scanf, you want to tell the person that they need to type something in. Type in a whole number. All right, so now if I compile it and run it again, I see a message, type in a whole number. Oh, okay, I'm supposed to type something in here. We'll type in the number 2. And there we go. And it'll save that number into X. All right, do you all have any questions for me? Any questions over that first introductory chapter? Then let us move into the next chapter. And we're still kind of covering some basic stuff. Let's look at how to do arithmetic and how to do Boolean, how to use Booleans in C. So we talked a little bit about Booleans in the last chapter, right? Or in the last PowerPoint. We mentioned that C doesn't officially support it. You know, it represents 2 values, true or false. Boolean logic, it is actually a type of algebra, but every expression that you write can only have 1 of 2 answers. So unlike a regular expression, like regular algebra, there's an infinite number of right-hand sides, right? The answer could be a lot of different things. In Boolean algebra, that's not true. There's an infinite amount of expressions you could write, but the right-hand side is always going to be true or false. Those are the only 2 values you can ever come to in Boolean algebra. There are 2 types of operators that you'll see in Boolean algebra: relational and logical operators. Relational operators compare numeric values and return a Boolean result is 10 greater than 2, for example. And logical operators combine Boolean values to come up with another Boolean value. So let's take a look at an example. You're probably all very familiar with most of these, right? Greater than, less than. This is a combination of two, less than or equal to. Recall we mentioned that in C, a single equal sign always means you want to do an assignment statement. So if you want to use the equal sign as an operator, you can't put any spaces between that and the other symbol. So if I want to do less than or equal to, I would write the less than sign immediately followed by the equal sign. Don't put a space in between, or it's going to try to interpret that as an assignment statement. If I want to do an equality comparison, is this number equal to that number? Use two equal signs. And then of course, the not equal exclamation point followed an equal sign is how you check to see if two things are not equal, and it'll return true if they're not equal. So here's an example. If I were to use this in an expression, is 50 greater than 25? This would return true. Is 50 less than 25? That would return false. Is 1 not equal to 1? What do we think this would return? False, right? Because it's only going to return true if they're not equal, right? Very good. So is 14 greater than or equal to 14? Yes, it's equal, etc. And remember, equality, you need to put two equal signs consecutively, no space in between. Don't put a space in between them. Logical operators, we're only going to look at 3. The 2 ampersands, and these, similar to the previous one, accept a value on the left and the right, or this one does. If the value on the left is true and the value on the right is true, this will return true. For any other combination, it would return false. So the AND operator, both operands have to be true. We'll skip to the bottom one. This is the OR operator. Use 2 OR bars. It's right over your enter key. You hold shift and hit the button right over your enter key. 2 OR bars. This will return true if either one of the operands is true. Doesn't matter which one. If either one of them is true, this will return true. And the exclamation point always produces the inverse. So if I put an exclamation point before some Boolean value, let's say I put it before true, it's going to return false. If I put it in front of false, it's going to return true. Remember, in C, we don't have Boolean. There's no such thing as a Boolean data type. So that is the same as that, right? Remember, 0 is false in C. So if I were to do this in C, that would be interpreted as true because 0 is false. Anything else, this would return false because anything except for the number 0 is interpreted as true. And I put the negation operator in front of it, and I reversed whatever that was. So you don't need to include any additional libraries if you want to use one of the Boolean operators. You could, if you wanted to, define a variable called true or false if you wanted to use true and false in your code. So if I wanted to be able to say, we could, what we're doing here, we're saying I'm creating a new data type definition that's called bool. What is the actual data type? It's actually an integer. If you import the library, that's what they do. So here's the actual data type, but I want to call it this. So every time I type bool, it's really an int, but I'm allowed to type the word bool now. And then you would just define some values. If you use the word true, it means 1. If you use the word false, it means 0. And that would allow you to do something like this. Well, let's go this first. Now I could write, we haven't looked at if statements yet, but I could do something like this now. If true, or I can make a variable Boolean b value equals false. Now we can use the words true and false in our code if we wanted to, instead of doing what you saw me do earlier, use 0 or the number 1 or something else. You could also just include this library, kind of like I did here. Include standard Boolean library, standard bool.h. And then you could use either one of these as the data type names, and you could also use the word true or false in your code. This is kind of what they do in that file if you include it. All right, let's stop there for today, and we'll pick up here, I guess, next week. Do you all have any questions for me? Any questions for me? All right, in that case, have a good evening or good weekend, everyone. I'll see you all next week.